Once again, we are talking about functions. Today, we are talking about odd functions and even functions. Odd function. Function is said to be odd when if negative x equals negative fx. If example, let's say fx is x cube minus x. What happened instead of if I put negative x in place of x? So that would be f negative x. That would be negative x into the power of 3 minus negative x. So that would be negative x cube plus x. If I take negative 1 as a common factor, it would be negative 1 times x cube minus x. So that would be negative fx. So if negative x equals negative fx, therefore we can say x cube minus x is a odd function. What about even functions? Even function is where f negative x is actually equals to fx. Example, fx equals x squared minus 1. So what happens if I put negative x is in place of x? So that would be negative x into the power of 2 minus 1. That equals x squared minus 1, that is fx. So the point to note is when it comes to graphs of even functions, they are symmetrical. They are symmetrical about the y-axis. What does that mean? Let's say this is y-axis, this is x-axis. So let's say this is the graph of fx, and fx is an even function. So they are symmetrical about the y-axis. So this is what happens. So they are symmetrical about the y-axis. Now we move on to the modulus function. So I'll use a different color. So modulus function. Modulus function is defined as modulus x, let's say modulus x equals x when x is greater than or equal to 0, or else it would be negative x if x is less than 0. So this is how the modulus is defined. There are some properties of the modulus function. Let's say a and b are real numbers. Modulus of a b product would be modulus of a modulus of b. The division of AB modulus would be modulus A division modulus B. A plus B, the modulus of this one is always less than or equals to modulus of A plus modulus of B. So let's do some examples. Let's say A equals 5, B equals -3. Then modulus of AB is modulus of 5 into -3. That would be -15. Modulus, this is 15, because -15 is this value is less than 0, so negative times -15. What happens to modulus of A is 5, modulus of B is 3. So modulus of A into modulus of B, again 15. A divided by B modulus would be 5 divided by -3 modulus. That would be -1.667. That equals to 1.667. What happened to A plus B modulus? A plus B modulus equals A is 5 plus B is -3. Modulus would be -2 modulus, that's equals to 2. Modulus of A equals 5. Modulus of B is 3. Therefore A plus modulus of A plus modulus of B is 8. So 2 is less than 8. Therefore we can say modulus of A plus B is actually less than of modulus A plus modulus B. Now we move on to another property. Let's say A is greater than or equals to 0. and modulus of x is less than or equals to a. So a is a positive number, is positive. Modulus of x less than or equals to a. So we can say a is a positive number, therefore if x is greater than 0, x is less than or equals to a. X is negative, then we can say negative x is less than a. If I put this one on the number line, I can say this is a, since x is negative, so from this one I can say x is greater than negative a. So negative a. So condition 1 says x is less than or equals to a. So here. Condition 2 says x is greater than negative a. So here. So from this one we can say actually x has to be in between negative a and positive a. Let's say second scenario. A is a positive number, x minus k, modulus of that is less than or equals to a. Similarly, we can say k minus a x k plus a. So these are some properties of the modulus function. So next we will talk about sum and product of a function. Let's say f is a function of x and g is a function of x. So we define the sum as f plus g x, and this equals to fx plus gx. Product of function fg is defined as f g x, that is fx into gx. Let's say fx equals x squared minus 1 and gx equals 2x plus 5. What is the sum of these functions? F plus g x. Is equals fx plus gx. So that would be x minus 1 plus 2x plus y. That would be x squared plus 2x plus 4. If gx would be x squared minus 1 into 2x plus 1. So when it comes to domain of the composite function f plus g or fg is actually the intersection of domain f and domain g. Next we talk about the composite function. In the composite function, we look at a function through another function. Composite function, let's say h is the composite function of x, and it is function g through function fx. Example. Let's say fx equals 3x plus 2 and gx is x squared. Then the composite function hx would be g 3x plus 2. That would be, instead of x I have 3x plus 2, 3x plus into the power of 2. So in this case, domain of h equals domain of g and domain of f. When it comes to range, f is actually a subset of domain of g. So there's a special function here, that is the modulus function with composition. So for example, we can say y is modulus of the function fx. So this is a special case. And finally we talk about inverse function. Inverse function. For a function to to have an inverse function, it has to be a one-to-one function. Only one-to-one. So it is defined as f inverse x equals y if fy equals x for x belongs to range f and y belongs to domain of f. So if you graph f and f inverse, so let's say this is x, this is y, this is y equals x-axis, and this is your graph of the function f, and f inverse would be the mirror image of the function f through y equals x. So this would be the f inverse function. So there are some properties when it comes to domain and range of inverse function. Domain of f inverse actually equals to range of the function f, and range of the inverse function equals to the domain of the function f. And function of f inverse x equals x, f inverse into fx equals x. So these are the